So basically, what we have to do when we do an inverse trig function is we just literally have to have the inverse trig functions memorized, and then it's really easy. And you might have to do a chain rule in there where you have to multiply the inside, right? Like if it's sine 3x or sine -1 3x, you have to do the trig function of inverse of sine, and then just multiply by 3. Those are the hardest. Inverse of g and f functions, what you actually have to do if you want, so here it says the function f of x equals x to the 5 plus x, and it has an inverse function of g. So that's the key thing we have to notice in this question, is it says inverse function g. So g is not the first derivative, g is the inverse function. What is inverse? We did it in 30-1. What's the inverse? When y's become x's and x's become y's. If you remember that, these are easier to do. Okay? So it's not saying find f prime of x, correct? Did it say that? No. It's just saying find g prime of 2. Well, I would have to have the inverse function first. Now, it's going to be a real ugly one to figure out because you're going to have y5 plus y, and then you're going to have to do the derivative of that, which is awful and ugly. So there is a way to do inverse functions without having to actually do all the finding of the inverse. Okay? So, if g is an inverse, g prime of x is literally just 1 over f prime, if this is x0, f prime of x0. Whatever x0 happens to be. Now, x0 is the actual x on g. It's the x on g. We agree? So if I say g prime of 2, this is the x on the inverse, correct? So x equals 2 is on, this is going to be the key thing you have to understand, is on the inverse. We agree? So what the heck would that be on the original? No. No, your x, you just told me. What's the difference what happens when you find inverse? X's are y's and y's are x's, and you guys are doing reciprocals. Stop the madness. Okay? So if x equals 2 is on the inverse, then that's actually the same as y equals 2 on the original. Do we agree? Okay. So if I plug that in to my original, I'm going to plug it in for the what? The f of x, the y. So I'm going to get 2 equals x5 plus x. We agree? And now I need to find its x. Where does it happen? Great thing is they let you have your calculator for 99.9% of these. If not, you'd have to move the 2 over and do synthetic division. Correct? But you're allowed to calculate for most of these, so we're going to go into the calculator and we're going to y1, y2 it. So our step 1 is to find x given y from our inverse. So yes, x equals 2 is the x on the inverse, but that is our y on the original. We know that because that's how inverses and originals work. So what did we get for x equals? Yeah. It's x equals 1. We agree? Once we have that, we have step 2 and we're done the question. That's it. So it's more of an understanding thing. Step 2 is where we're going to go g prime of x of 0 equals 1 over, well, this would be of x, sorry. It shouldn't be x of 0. This should be x and then x of 0. So I'm doing g prime of 2. This shouldn't be x of 0. It should be just x. G prime of 2 equals 1 over f prime of what? 1. This is your x of 0. So you have to take your first x from your inverse and plug it into your y to get the actual x to fill in. Because if you plug 2 in here, are these the same x values? No, this is actually a y value on this graph, correct? So I can't plug a 2 in here. I would have to plug it in for like the whole thing because it's a y value. This is a y on f of x, correct? So I can't plug that in. We agree? So I have to find the x that correlates with that y, which is a 1, and then find the derivative of that. So we're going to get 1 over, what's f prime of 1? What is f prime? 5x to the 4 plus 1. So we get 5 times 1 to the 4 plus 1, which is 1 over 6. Done. So there's 2 steps when they ask you an inverse that's not a trig function. Yeah.
What is that x base 0?
It's just giving it an x of like an original.
Oh.
Yep.
What is the 1 over f prime of x 0?
It's the formula you use. Yeah. Whenever you find an inverse derivative, you do 1 over f prime of the original x. Yeah. Okay, let's look at this one. It says the function f of x equals x cubed plus 2x minus 4 is 1 to 1 and has an inverse function g. So here, this is where that's where you're going to have to spot. You're going to have to see a question and it's going to tell you, hey, the inverse function is g. It's written in there. Okay? That's when you know to do this. So it says find an equation of a tangent line. I don't care about the tangent line equation right now. I just want g prime of what? Okay, so it says find an equation of a tangent line to the graph at 8, 2. So g, this is a point on g. So this is x, y, we agree. So I want g prime of what?
8.
Of 8. Of its x. We agree? Not the same thing. Totally opposite. So we want g prime of 8, which we know 8 is actually what on the original? 8 is
Y, sorry.
y. Y equals 8 on original. So this is my step 1 I need, correct? Step 1 is to take, it's a 8 equals x cubed plus 2x minus 4. This is my step 1. And then what do I have to get? X equals whatever. So typing it in, y1, y2. Y1, y2. Nope. It is. Because we said, what do? We swap our coordinates, correct? I'm doing step 1 to prove a point, and you're completely correct. A lot of the time, they'll just give you coordinates, not even an equation. So they do the work for you. They'll say f of 3 is 2. Well, if f of 3 is 2, then I can just plug 2 in. Like, they'll do the work for you and not even give you an equation. You guys find those harder. You're like, I want to do all the work. This is 2 hours. And I'm like, no, it's easier. Okay? So we have x equals 2, and then we need to go, okay, g prime of 8, this is step 2. What are we going to do? Equals 1 over f prime of 2. Yeah, which is x0. I get it. I thought you were saying x equals 0 at first, and I was very concerned. Yes?
Why did you put it over 1 or under 1?
Because it's the formula for inverse. Derivative of an inverse. To find the derivative of an inverse, you do 1 over f prime of 0. F prime of x0. Like it's a formula you need to know. Okay, now if this was one where they didn't give us an equation, but they gave us f prime of 2 equaled 6, it would just be 1 over 6. It's easier. that you guys would get stuck, okay? So if they like give you f prime of 3, you just then fill it in, right? It's easier, not harder. Okay, so f prime of 2. F prime of x is 3x squared plus 2. F prime of 2 is 3 times 2 squared plus 2, which is 14. Yeah, 20. 2 squared is it's 14. I know, people were throwing me Okay, but we're not done. That's just what? That's just the tangent slope. So we have to go y minus y1 equals m times x minus x1. So it's going to be y minus 2 equals, maybe a Khan Academy video, just kidding, 1 over 14, and then x minus 8.
Can you, that would be if we were written response, you wouldn't have to put it in.
No. Unless they ask for it in a specific form. Okay, I'm going to get you guys to start working on these. We're going to move on in a few minutes, but I'll let you start working on these ones. This one here and this one here. There's a little formula for lns and logs, and it depends on if there's an x or not. I consider these in the chain rule situation. When you do a derivative of a ln or a log, remember how with e, all you did was you rewrote it, ln the base, derivative of the exponent, correct? Okay? And if it was a variable, or if it was a numerical base to an exponent, we did the same thing. So it's like 4 to the x. We'd go 4 to the x, ln 4 times 1. We did the same thing, correct? Logs and lns are the same-ish. So what we did when we did exponentials is we rewrote it, ln the base, times it by the derivative, correct? Now what we're going to do with lns and logs is we rewrite it, but in the denominator. Ln of the base multiplied by the exponent, by the derivative of what's beside it. So what ends up happening is the two things that we had before just go into the denominator, and the derivative of what's in the bracket goes to the numerator. That's the only difference of logs and lns. And it's because they have the base. And remember, logs and lns are inverses of each other, so that's where you're going to get that 1 over. So that's why we did the inverse thing first before this, because we did 1 over the derivative of the original, correct? This we do 1 over the log. So if I look at this one, all the lns will actually have no ln base anything in the denominator. Why? Because ln of e is 1. That's why. So they're still going to go away, just like when we did e to the x ln e. That went away. Correct? Same thing. So let's look at the ln one here. So what did I tell you to do when you do differentiate a log function? Which a ln is a log function. It's log base e. That's all it is, right? What I told you do, and I just said this, is you rewrite it in the bottom. So I rewrite it. But can I do that right now? What do I have to do first, guys? Chain, yeah. I have to chain rule first. So I'm going to just go. Oh my goodness. Not the eraser. Okay. So we're going to take the 2, we're going to drop it in front, and then rewrite ln x, and it would be to the 1. Do I need that? No. And then I multiply by the derivative of what's inside, correct? This is where I do my ln derivative. So the derivative of ln x, what do? I rewrite it in the base. Not the ln part. I rewrite the x in the base. And then I multiply by ln of the base. What's the base? E. So I write what's beside the ln here. Derivative of the base, or ln of the base, derivative of it up here. Oh my gosh, this is sounding way more confusing than it is. What's the derivative of x? 1. That's it. So it's 2 ln x over x.
What are we finding?
The derivative.
Why? Why?
Why what?
Why is it thing in the bottom?
Because that's the rule of a derivative of a ln. You take what's beside it, drop in the bottom, ln the base, derivative of it on top.
Say it again.
You take what's beside it, put it in the denominator, ln the base. So the base of ln is e, and a 1 on top. All right. Instead of saying, like, I don't understand it fully after I've done one example, I expect that, just so you know. Like, I've done one example. You guys are like, I don't get it all completely, perfectly. I can't do all the assignment right now. One example. There are these ones, and then if you look directly below it, there's some more. So we're going to chill for a second, because I believe in you. Yes.
Where did the E come from? Like the long E.
So you write ln of the base, and the base of a ln is e. Because ln is log base e. Can we just stop? Okay, we're moving on to the next one. Because it will make more sense as we do a couple more. So can we just stop? Ln is log base e. So if you don't want to write ln, you could write log base e. It's the same thing. All right. If this one doesn't have a base, what's the base? 10. So when we have a coefficient in front, what happens? You can just leave it. You can just rewrite it, right? You could do product rule, but it'll just kick out the other half. So whenever there's just a coefficient in front, we rewrite it and then do the derivative of what's behind it. We agree? That has not changed in any of our derivatives. So we're going to get 1/2. Now we have to do the derivative of a log, which a ln is a log. It's log base e. A log without a base is a base 10. If there is a base, it's like 2/4. It's rewritten. We agree? Okay. So you take what's beside the log or the ln, whatever it is, and it goes in the base. So what's beside it? X. What's beside the log? In the brackets. An x. And then we do ln of the base. What is the base? 10. It's just not going to go away this time. This one, I could have rewritten as 2 log base e of x. We agree? So I wrote ln e because that was my base this time. It's just that ln e goes away. This one is ln 10. And then I do the derivative of what's in the bracket on the top. What's the derivative of x? 1. So I get 1 over 2x ln 10. Sorry?
So like you said that, like sometimes when they give like Newton's first principle questions, they'll put the formula in the question. Like,
That's only to force you to do Newton's first principle. They're not going to give you the formula and say, this is how you find a log. No. Step 1, do that. No, they're not. We're going to skip C for a second because I think you will all crumble and die, and I would love for you to live another day. So we're going to skip C for now.
You're so merciful.
I know. And we're going to go to D. I'm going to put the x cubed in a bracket. And if it's sitting beside it, it's the cubed. If the log was all to the 3, the whole thing would have been bracketed to the 3. So it's on the x if it's not all bracketed to the 3. We agree? So it's just that. Okay. So how do we do a derivative when we see a log? We see an e. We now know e to the x, log e. How about that, right? You're going to be in the same boat in 2 days. But you're freaking out right now and be like, can I have the formula? There is no formula. Okay? So you will be fine. You guys do this all the time and then you come around. So, okay. It's a log or a ln and we have to differentiate it. We're ready? So what do? Y prime equals. What's beside the log goes in the base. Then ln of the base. What is the base? 2. And then the derivative of what's in the bracket on top. 3x squared. Well, no. Because there's stuff that can cancel here. There's an x squared can come out of here and then an x squared out of here. Because they're multiplied. When everything's multiplied, you can cancel. If there was like a plus or a minus sign somewhere in here, you could do nothing. Just call it a day. Yes. Y prime equals 3 over x ln 2. you always have to simplify. It'd be like if you just did product rule and wrote FG prime plus GF prime and left it like that and in response and expected them to give you full marks. They're not going to. Yeah, you have to keep going till it's simplified.
But then the point slope form.
That is point slope form. It's a form. So that is like, you're just used to always having it in y equals mx plus b, but that's not the only way to have a linear equation. So that would be okay because that's an actual form that exists. You know what I mean? Yeah, so there's standard form and there's general form, like we did that in quadratics as well. There's one where we did vertex form, and then there was one that we did standard form where all the brackets went away. So there's different forms of way you can write equations, but this is like simplified down. So that's not really simplifying, it's a form. Does that make more sense? Yeah. Okay. Ln 5x. I'm not making too any homework on this. We're just using our brain power. I believe you. So, ln 5x is log base e. If it makes your heart sing, write log base e. Okay? If that makes it easier, please do it. There's nothing wrong with that. So, when we have a log or a ln, which is a log, we do the same derivative over and over and over. We write what's beside it in the denominator. Ln of the base, derivative of what's beside in the numerator. Every single time. And you're like, I'll never remember that. You remember the e stuff, I promise. You remember this. It's the same thing. Like you practice, you remember. You practice, you remember. So y prime equals, so what goes in the denominator? 5x ln e, which happens to be a 1, so it goes away, and then 5 on the top. So now I actually have 5 over 5x, which is 1 over x, because these are all multiplied. If there was a plus or minus sign in here, like if there was like 5x plus 1, I would be done. I would box it. I could not cancel anything off. But these are all multiplied up here and in the bottom, so they can cancel. When the numerator completely cancels off, I'm still left with a 1, so y prime is 1 over x. We're going to try B.
Oh, the ln e goes away.
Yeah. You're correct. What is it B? There's an x in front, so I have to use product rule. So this is an f. Guys, seriously, the derivative of the first one is 1. No. Stop. F. G. You guys are like, you give up way too easy, I'm afraid. F prime is 1. G prime is a log base e. We agree? So when it's a log, we rewrite what's beside it, then multiply it by a ln of the base. The base happens to be e. And then derivative of what's beside it, 2x. So ln base e turns into a 1, or ln e turns into a 1. Now this is the case where I said you can't simplify. You have a 2x and you have an x squared plus 1. X squared plus 1 is a whole term. The only way it's going away is if there's an x squared plus 1 in the numerator, which there is not. So when there's a plus or minus sign, please do not cancel them off. You're killing kittens. You stop. Like, that's how evil it is. It's so bad. So we're going to get 2x over x squared plus 1, and this is all taught in grade 10 and then reiterated in grade 11, and then I reiterated it, yep, in grade 12. Okay, so we just fill it in. Remember, we're filling in, when we fill in x, we're either filling in an x or a 1. So I believe in you. You guys can do this. I believe in you. So we do f, which is x, times g prime, which is that? 2x over x squared plus 1. Plus g, which is ln x squared plus 1, times f prime, which is a 1. So what do we get in this first half? 2x squared, because this is over 1, right? 2x squared over x squared plus 1. Can I cross off the x squareds? No, because this is x squared plus 1. I'm putting in brackets to prove a point. You can't just like cut that off, right? Okay? Then plus ln x squared plus 1. And they're so nice, they don't make you do common denominators, they just make you box it. No. No, that's not what I just said. I said these ones, they don't make you do common denominators. Any of them? No common denominators in all of calculus? Is that what I just heard?
Do it 1, 2, 3.
To match.
Match, okay. But for written response, how would I know?
You could stop it. It's simplified.
Okay.
Yeah. The difference in like getting a common denominator, the only reason why you would do that is if you could still cross something off. So like if I went x squared plus 1 and x squared plus 1 and that would get my denominator cancel off, then making a common denominator would be more helpful. But if it's, I'm just adding more crap to crap. If I asked you like domains and ranges, it might be easier if you do that because you could restrict, like, you could do your like asymptotes and stuff with the denominator. So, yeah. All right. Work on your homework from last day or take a break, but that's really not that bad. Well, I know that some people did not do Friday, and I